Okay, so now we are continuing with the Walmart quarterly sales data. So in the previous model, we looked at sales as the y-axis value and L1 GDP lagged by 1 quarter as the X range, the independent variable. And we called that model number 1. So now when we did the residual analysis, okay, we figured out that seasonality should also be included, and we're going to define dummy variables for seasonality. So we did dummy variable for categories, like what kind of TV ad option we're going to use in the first example. So now we are applying the dummy variable concept for capturing the seasonal variabilities in sales. So let's define the dependent variable and the independent variable. Okay. So quarterly sales, dependent variable. So L1 GDP lagged by 1 quarter, and the quarter to which the observation belongs. And there are 4 values, Q sub 1, Q sub 2, Q sub 3, or Q sub 4. So we're going to define dummy variables for quarter, and remember we need only K minus 1, 4 minus 1, meaning only 3 dummy variables are needed, exactly 3, no more, no less. Okay, so let's define the dummy variables now. Okay, 1, 2, 3, Q sub 1, Q sub 2, Q sub 3. Okay, now let's set up the data. Okay, so now we have L1 GDP. So now we need Q sub 1, Q sub 2, Q sub 3. Okay, so we're going to leave the first row out because we don't have L1 GDP for the first row. So now we have to set up the dummy variables. Now if quarter, okay, so now this time this column L, the category column, has non-numeric values. So you have to enclose with quotation mark. So this dummy variable is Q sub 1. So you're looking for the value Q1 in that column. If that is Q1, then this dummy variable will get a value of 1. Otherwise, it's going to get a value of 0. Now, this one then is if quarter is equal to, again, enclose with the quotation mark. So if it is Q2, then this dummy variable is going to get a 1, otherwise 0. And then we have if that is equal to Q3, then you get a 1, otherwise a 0. So you don't need Q4, only 3. Now we copy these 3, and remember these 3 variables, they go together. They must stay together always. So now we can run our regression analysis. So let's do a data analysis regression command. Our Y range is sales, okay, and sales will have to start from there. Okay, and then the X range is starting with L1 GDP, then Q1, Q2, and Q3. Okay, so there is no labels here. Okay, let's put the output range right there. Okay. Let's do the residuals, these two, like before. Okay, so we can then, after having included Q sub 1, Q sub 2, and Q sub 3, and we can see whether that took care of the seasonality that was present in the residuals. So we have the output. Let's do the probability plot in just a second. So let's first set up what Y sub 1 estimate is. So here let's give the variable names. Let's copy the variable names from right here. So that's that. First one is L1 GDP, and then Q1, Q2, and Q3. So now our estimated regression line is, okay, so constant y-intercept, L1 GDP, and then we have Q1, Q2, and Q3. So remember, the coefficients must be interpreted as compared to the dummy variable that was not defined, not included, which is for Q4. So all of these are compared to Q4, fourth quarter. So quarter 1 would be 11.24 less. Compared to quarter 4, quarter 2 will be 7.54 less. Compared to quarter 4, quarter 3 will be 9.73 less. Okay, with GDP, L1 GDP being the same. Okay, so now R squared is right there, and standard error is that one. Okay. Now if you compare this with model 1 from the previous sheet, okay, R squared was 96%. So the improvement in R squared now being 99%, it is better, but it's in the same ballpark. But if you look at the standard error, you'll see that the standard error has become half of what it was. Like here it was 5.06, and here you see it's 2.5. So that's a significant improvement by way of reducing the standard error. So now let's look at the plots. Okay, this is our normal plot, and I'm going to quickly give you the results, and you can do the plot. So when you plot the residuals on the y-axis and predicted y on the x-axis, in this case, so this is the plot you'll get. And here you see that this plot looks about the same as in the previous case. Okay, now let's do a plot over time. And if you look at residuals over time, now you see that the seasonality that was evident is no longer there. It's still going up and down, but not in a regular pattern like what we saw in sheet 2. So let's look at that one more time. Over time, you see there was a kind of a predictable kind of going up and down. Okay, that's no longer there. Now let's do a histogram. Okay, once again, we're going to do the residuals. I'm going to give you the final results of the pivot table. Okay, insert pivot table. Okay, when you do the pivot table, the residuals must be counted and not summed. So you have to go in here and change it to count, and then we have to group it. So let's do a grouping. So we'll go -4 through 8 in increments of 2. Okay, I'll do a pivot chart of that. I'll clean it up. Okay, close the gap. And we'll put border. Okay, so now the histogram of the residuals looks more closer to normal distributions, kind of symmetric. So that's a good sign. So once we introduced the dummy variables for seasonality, the residuals are looking a lot better. It's a lot more random, and it follows normal distribution and so on. So one final thing is the ACF. So let's do the ACF. Once again, go to ACF, run ACF, and the Y range is residuals, and let's do 12 lags, labels, and let's put the output somewhere over here. Okay, and then format. Okay. Now let's look at the autocorrelation function, and the seasonality is now gone, and then there is quite after a couple of lags the autocorrelation goes down, so maybe there is a little bit of trend still present, but then you see that it is this pattern is pretty good with respect to seasonality. So by introducing the 3 dummy variables for representing the 4 seasons, 4 quarters, our analysis, our model has become much better, and we'll call this model number 2.